Welcome to myprojectbazaar.com. Let we discuss about the process single image super resolution via linear mapping of interpolated self examples. Let me see the abstract of the process. Image resolution is always a key feature for all kinds of images, with ever increasing sizes of the displays needed for super resolution images has also been increased. This is also impacted by the limited size of the digital image sensors. Resolution enhancement is always being associated with interpolation techniques. Research suggests that the interpolation methods increases the intensity of the low frequency components. This means interpolated images will have less number of sharp intensity transactions per pixels. The process of super resolutions is more important in the analysis of the identification of the important information from the images more accurately. The enhancement of resolution of images were employed based on the decomposition of the images. Basic functions of the wavelet transformations are small waves located in different times. They are obtained using scaling and translation of a scaling function and wavelet transformations. Therefore, wavelet transformations is localized in both time and frequency. The image decomposition is employed based on modified wavelet zero padding. The modified wavelet padding includes the usages of the two different wavelet decomposition methods, DWT and SWT. The wavelet transformation decomposes the images into different coefficients based on different wavelet filter banks. The high pass and the low pass filters were employed based on the filter results. The coefficients were identified. The input images were first resized to 256 cross 256. The images were subjected to decompositions based on both SWT and DWT. While applying DWT, the original images were simplified into 4 coefficients. The coefficients were minimized in size compared to the input image size. While applying SWT, the original images were split into 4 coefficients. The coefficients were of the same size compared to the input image size. The DWT coefficients were resized to the size of SWT coefficients by using zero padding. The zero padding process is employed by creating an empty matrices of the size of the SWT coefficients and placing the DWT coefficients in them. The inverse transformation is employed and to the obtained modified coefficients, the remaining of the SWT coefficients. The resulting image will be of resolution enhanced, which will be of the size 512 cross 512. The zero padding preserves the image informations in an efficient manner, and hence the distractions in the enhanced images were much reduced. The performances of the processes were measured in terms of PSNR and the MSE values calculated. The high PSNR values indicates that the images contains minimum distortions. The PSNR value is high and the MSE value is low in our proposed system. Modified wavelet based zero padding. The SSIM value is also measured and is near to 1 in most of the cases, which again proves that the proposed method is more efficient. Let us see the flow of the process. The input images were initially taken. The images were resized to the common size 256. This is to compare to which size the input images were increasing. So after resizing processes, the DWT decomposition and the SWT decomposition were employed. So as we can see, both using DWT and SWT, the 4 coefficients were obtained. So the DWT coefficients were of minimum size and the SWT coefficients were of the same size as the input images, that is 256 cross 256. After that, the zero padding processes is applied for the high coefficients of DWT and the SWT. So for zero padding processes, empty matrices of the size SWT HH is obtained and paste the DWT HH in the particular location. We obtain the new HH. So after that, we use the SWT low, SWT high low and SWT LH for the reconstruction processes. So these 3 parameters combined with the high coefficient, newly generated high coefficient, the inverse DWT transformations were applied. The property of inverse DWT transformation is to increase the size of the input image size, and hence the size will be automatically increased, resulting in the production of high resolution images. Thus, we have obtained high resolution images from the input images, and also we have measured the performances which is based on PSNR, MSE, and structural similarity calculation. The super resolution process is employed here. So let me see the running procedure of the processes. In the proposed super resolution model, the process can be applied for gray images and color images also. So for gray images, run the file main.gray.m, and for color images, run the file main.color.m. So first run the file main.gray.m. So right click the file and click on run file. The process will get started. So select any one of the gray images. So we select the gray images at first. So the process executes as like this. So this is the input images that we have given. First, the DWT wavelet transformation is applied to the input images. For DWT wavelet transformation, the images were split into 4 coefficients. So low, high, low, and high. So these are all the separated coefficients for the input images, and these images were combined as a single image and it is displayed here. This is for displaying processes. So the input image is decomposed using discrete wavelet transformation. Similarly, the same process is repeated for the stationary wavelet transformation. The main difference between them is while applying discrete wavelet transformation, the input images were decomposed in the size which is reduced compared to the input image size, and in SWT the input image size will be the same as it is. So this is the DWT coefficients applied, and as we can see, this is the SWT coefficients obtained. So these SWT coefficients will be of the same size as the input images. So thus we can combine this, we get the result like this, and this is the final super resolution images that we have got, and the overall performances of the processes were measured in terms of MSE, PSNR, and SSIM. So as we can got, the PSNR value is improved and the SSIM value is near to 1, and the MSE value is also good. So thus we have applied the super resolution process for the color gray images. Similarly, we can repeat the same process for the color images also. So for color images, select any one of the color images which is present in the dataset. So this is the super resolution image, and this is the results that we have got. So thus we have employed the super resolution methodologies which is based on the modified wavelet transformation methodologies and zero padding methodologies, which is used for the combination of the DWT and the SWT coefficients. Thank you.